Hello everyone. So today I'm going to be going over Leetcode problem 44, wildcard matching. And let's start with the definition. So given an input string S and a pattern P, implement wildcard pattern matching with support for special character question mark and special character star. So the definition of what these two special characters accept are here. Question mark accepts any single character, and star matches any sequence of characters, including the empty string. And then just small notes, they can only be lowercase letters, which is fine. We don't really care. That's not a problem. So just some small examples, right? Pattern A does not accept string AA, right? So that's a false. Star does accept string AA because it's any sequence of characters. A star C question mark B is not accepted because A matches. And then if star is an empty string, maybe, I guess if star is an empty string, then we need a DCB. Well, we have a question mark and then a B, so we couldn't possibly match. But maybe star, is referring to this C and D. And then we have a C here, so that matches. Then we have a question mark, and question mark has to match a character, so it matches to this B. And then this B is left over, and we don't have a match for that B. So perhaps a little bit too complicated of an example to really explain without sort of drawing stuff, but we can sort of go into how to think about this problem. So upon first thought, maybe this problem seems kind of hard, and I don't know, how can I think about whether or not a pattern given some arbitrary string accepts that string without computing a whole bunch of stuff, a whole bunch of paths, maybe like going back to the problem, maybe this star is referring to this string, or maybe it's referring to the empty string, or maybe it's referring to this string, or right, every time we see a star, it seems to blow up exponentially what we have to do. But in reality, what if we rephrase this question, and this is typically, so this is a sort of a classical dynamic programming problem. It just basically rephrased a little bit. But what if we think about this question? Given I and j, does our pattern from P to from 0 to I accept string from 0 to j? So if I and j are actually at the end positions, then that's equivalent to the original question, which is asking, does the whole pattern accept the whole string? Right? So can we use the fact that maybe we can solve for smaller segments? Like maybe if I was here instead, and j was here, can we use that to solve maybe for if I was here and j was here? Can we think of that? So if we have some string as some pattern, right, and these let's say I told you that this red box is some pattern chunk that we don't know and we'll never know, and this string is some sequence of characters that we don't know and you'll never know, and I'm an oracle and I can tell you that these two match. I can tell you that instantly, and I can say that with 100% confidence that these two chunks match. And then I gave you a little peek at what the next part of the pattern in the string was, and it in fact turns out to be the end of the string in the pattern. And I said, does this pattern accept this string? Right? Even though you don't know, the only thing you know about these two bits is that they match. You should be immediately able to tell me that they do match because of the following logic. A matches with A, and every bit before that matches with every bit before that, right? So that sort of logic is what we're going to utilize in dynamic programming in general, and what we're going to utilize in this problem specifically. So the logic for if we see a character, say A, is just from this position, Sj and Pi, right? If we have Sj and Pi, the teal box, and from this position, the purple box, is that statement true, right? So maybe this is false, or maybe this is, well, this is true. We'll just keep it consistent, and true. So that's true. So maybe that's like a start logic for how we can think about if there's a character here. But we don't only have characters, unfortunately, right? We have stars and question marks and wildcards, basically. So how can we think about this sort of in a solvable way, right? Like a computable way. Like what I was doing before was just basically like abstract and sort of maybe not that helpful, but when it comes to programming. But programming, is just a result of the underlying logic, which ultimately is pretty strong and clear in this problem. So what if I and j are like off the string to the left, right? What if we're looking at the empty string? So these two positions, do these match? Well, yes, the empty string always matches the empty string. So there's a true here. And if we sort of follow this logic, just sort of maybe we'll follow it, not exactly, but general guideline for right now. We can go row by row and column for each row, and we can evaluate the matrix at this position. And just a small note, thinking about string or pattern or string alignment, anything like that, in general, it's safe to start with some sort of matrix that you line up the two strings with. It doesn't always work, but it can be a good start, and it can be a good way to sort of start thinking about, if you have two strings, how can I determine the answer? So does the empty string match A? No, empty, and it won't match any of these. So filling out the first row, maybe we also want to fill out the first column first as well, just like sort of as an initialization step, right? Because technically we haven't looked at the pattern or the string yet, and this could be just an initialization step. And that's generally pretty smart to do. If you start thinking of the logic behind the star, you'll see actually that we do need to fill out the first row and column first. And I'll explain that a little bit later, or maybe you'll see it yourself. But does A match, right? If we move forward in the pattern and not forward in the string, does A match the empty string? No. Does star match the empty string? Yes. But the problem is if we take this pattern, right, up to this point, remember we're trying to ask the question of is the string accepted by the pattern up to this point? So empty string A star, is the string empty string accepted by this pattern? It should be no. So we can't just look at star and this position and like fill in a true here. That can't be the logic. So if you think about the star, what it's doing, it's saying basically, hey, I don't care what's at me or after me. I accept it no matter what. Remember, it accepts any sequence of characters. So we know that from this position on, right, we know that if we got to this spot and it's been accepted so far, then everything else will be accepted as well. So if we got to this position in the pattern, and then we saw a star after moving to this position, we would know that the star would accept. But since we can look at this position and see that there's a false here, the star will also be false, right? So maybe upon first glance, the logic for star looks like it just takes the top cell and fills in a false, or fills in whatever that cell is. And then the A clearly doesn't match the empty string, so that's a false. So now we really get to this bit of logic here. We start in the beginning with AA, right? So does A match A? It does. So let's just say we put a true here, right? Let's say we just don't care about anything else and we just fill in a true here. So A match B, no. A match C, no. A match A, yes. But the problem is this true is actually wrong, right? The pattern A does not match the string ABCA. So there can't be a true here. So if we think about sort of go back and think, and we look at this, we need to actually look at one position left in the pattern and one position left in the string in order to answer this question. And that so happens to be this cell right here. C is the character before the A, and the empty string is the pattern character before this A, right? So the only way to get to this A, match this A with this A, the only way that we really care about actually is if we move forward in the pattern once and forward in the string once whenever we see a character. So if we look at this cell, that's what this cell exactly is. So we know that this cell, so far up to this point with this cell, is false, which means even if this A matches with that A, it has to be a combination of A equals A, which is true, and the top left, which is false. So that equals false, right? So this cell is going to get false. That's the logic for that, for if a character matches with a character. So what about a star, right? If we let's say we look at the cell above. Let's say we keep our logic. Look at the cell above. Then we'll fill in a true here. Does A star match A? Yes, it does, because star matches any sequence of characters. Okay, let's look it up here. False. Does star match AB? Does A star match AB? Yes, it does. So we can't, so that's not the logic there. So let's think about sort of what the logic means for it to be star. Star is fine with any sequence of characters after this coming from the string. So basically from this position on, once we see a true, right? Once we evaluate that one true, we don't care what any of these characters are. We know it must be true. So how do we determine that? We determine that by this one, right? We looked at here and we said true, and here and here. But for this one, we looked from here. So it looks like, and it makes sense if we think about it, the star actually pulls from, so far what we see, the top and the left cell, and it unions these two cells, right? True or false is true. But how else can we get to the star? We can also get to the star from the top left position. So actually the logic for star is the union of the three cells that indicate the three paths that we possibly could have gotten to when we align star with A. There's only three paths we could have gotten there. Skip here twice and then align, and then skip here once and align the star. Skip here twice, skip the string twice and then align the star going down. Or match or skip the pattern once, align with the A with the empty string, and then align the star with the A. So maybe that doesn't make sense. Maybe that was a little bit too much, but the star, the logic behind filling everything out from here forward, is because the star doesn't care what comes after. The only thing we have to do is determine when in the row the star first becomes true, and that was the logic I was explaining. So does A match A? Yes, but as we can see up here, we up to this point in the pattern, it's false. So true and false is false. Does A match B? No. Does A match C? No. Does A match A? Yes. And the top left cell is true. So our final value is always going to be in the bottom right of the cell, because that's the question we're trying to ask. The pattern up to I does it accept the string up to j? And the bottom, the very end of the cell, the very end of the matrix rather, sorry, the last cell, that reflects that very question. So let's move forward to a slightly more complicated example. And let's see if our logic for star is held. So we can fill out this matrix as described earlier, right? The empty string is never going to match any of the characters in the string, right? This is the string and this is the pattern. And does the pattern of A match the empty string? No. Does the pattern of star match the empty string? Yes, but up till A we have a false, so this must be false. And then we know everything else must be false because at this point none of the characters are going to match. And any star is going to be pulling from the cell above it, so the second we see one false, it's just all going to be false. So does A match A? Yes, and the top left cell is also true, so it's a true there. And then we can just fill all of these out false because we know that none of these top left cells are true. And star, does A star match empty string A? It does. So if we pull from all three of these cells, we get a true. And then we can pull from the left cell, and all of these will be true. Does that make sense? A star, does A star match the whole string? Yeah, because A could be here, and then the star could be the rest of the string itself. All right, so does B match with A? No. C, no. No, no. Yes, it matches there. And the top left cell? No, no, yes. And this also makes sense because does A star B match the substring ACCAB? Yes, because the star can be CCA. Additionally, does it match, we have another true here, does it match the whole string? Yes, because the star can be CCABAD, and then we can have B as our last character. So this star doing the same logic for everything from here, true, true, right? Because we pulled this true from here. Does that make sense? A star, B star. Yeah, because A can be here, star can be here, B can be here, and then the other star can be there, right? So the last C, false, false, false. We'll just fill it out as usual, right? And C only matched these two characters, but since the top left for that is here and the top left for this position is here, everything is false. And you can see that this string doesn't match this pattern, right? Because it actually ends with a C. We could have actually determined that immediately. And there's probably a lot of edge cases like that you could reduce the runtime of your program, but algorithmically you're still going to, in the worst case, going to be doing this string times that string. So the orange highlight is asking the question, would you have accepted this string if the pattern was up to the orange line? A star, B star. And you would, because A is here, and then the star is up to here, and then the B is here, and then the other star is up to here. So if we look at 1, 2, 3, 4, 5, 6, 7, I equals 7, and J equals 1, 2, 3, 4, J equals 4. In cell 7 or 4, 7, 1, 2, so 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, 6, 7, right here. Actually, it should be right here. Sorry. No, it is the D. So the orange line, it's the B, sorry, or the D. It doesn't really matter. But this bracket I drew was ending on the D, but you could do it here too, whereas I is either 7 or 8. And you can see that it does, right? These values in these cells do tell you that the pattern up to that point and the string up to that point is accepted. So what about the logic for the question mark, right? We haven't gone over the question mark yet. And the question mark is really similar to the logic for matching two characters, because the question mark is basically, you can be any character, I don't really care. So we can, fill this out as usual all the way here, and then this doesn't match, so we got falses all the way there. A matches with A, true, and the top left cell. These are all falses as well. I'm just going to do this kind of shorthand so can save time. And then the star, right, we pull from the false here, here, and then we have a true there. So this gets filled in with a true, and then this is all true from here on out. And then the question mark, we get to a question mark. We haven't done this yet. So what is the question mark sort of asking? It's asking whether or not the pattern up to this point plus any character matches the string. So it's actually almost exactly the same logic when we see a character. We just don't care about doing the check between this character and that character to see if it matches. So remember what we did for A? We looked at the top left cell and we did a check. And if both of those are true, we get a true here. Well, for question mark, we just look at the top left cell and we put that value here. Right? So this is all falses from here down. So we don't care. And A star question mark doesn't match the substring A. So that is true. So does question mark, so we just take the top left cell, question mark, and then the question mark B, there's a true in the top left, so what if we put it there? Does A star question mark match AB? It does, because the star can be an empty string, right? So top left cell here, true. Does A star question mark match ABC? Yes, because the star can be B. And you can tell all of these are true, so it's going to be trues all the way across, right? Because the star could be any of this bit, right? So for the last character, E, we do the same thing, right? E doesn't match with A, B, C, A, D, but it does match with E. And then we look at the top left cell, and that's a true. So the logic for question mark is very, very similar to the logic for the characters. All we're doing is basically looking at the cell to the top left. And the reason why it's the top left is because when we move forward in one character, we go down a row. And when we move forward in the string one character, we move over a column. So that's equivalent to basically moving diagonally. And the question mark really is asking that question of, or is evaluating the statement of whether or not this character is equal to, or if there is a character at this position given the pattern we have, right? Because this will match any character. So we can go to the code and look at the code for this. Basically, I have an initial return immediately if the pattern is equal to the string. And then I initialize the matrix to all falses. And I fill out the first column as defined, as we talked about, where if it's a star, we just take the value above. Otherwise, everything is false because nothing will match the empty string. I set 0, 0 to true because the empty string matches the empty string. And then for each position in the pattern and each position in the string, I update the cells accordingly based on the logic. So it may be kind of confusing because there's like a +1 here and a +1 here, but that's just because if we look at this matrix, the empty string eats up the 0th index for both columns and rows. So actually when we're taking a character from the string, the J, which is 0 in this case, in the matrix, the correct corresponding cell, or column in that case, is 1. So like when J is 0, we want to be looking at the first column. So anyways, if it's a star, we take the union of all 3 cells. If it's a question mark, we just take the cell to the top left. And otherwise, it must be 2 characters. Or otherwise, in the pattern, it must be a character. And we just evaluate whether or not the 2 characters are equal, and we conjunction that with the cell to the top left. In the very end, we just return the bottom right of the matrix. So hopefully this was helpful and not confusing, and if it really doesn't make sense, I encourage you to go back and look at dynamic programming from like slightly simpler lens and look at the stair climbing problem, look at the coin making coin change problem with respect to dynamic programming. And as always, if you have interviews coming up, best of luck on them. Stay calm, don't try to cram, believe in yourself, have that confidence. I'm sure you'll do great. Thanks everybody for watching. If you liked, hit the subscribe button. More videos coming in the future. Thanks.